In this video, we are going to be going over how to solve one-step inequalities. I have a few examples for us to go over here, so let's go ahead and get started. All right, so inequalities are very similar to equations when we're solving. The only new rule that we have to remember is that anytime we are dividing or multiplying by a negative number, we need to flip the sign. We'll get into some of those examples down here with these last four problems. Let's go ahead and start with this first problem. X plus 5 is greater than 10. All right, so we're going to treat this inequality symbol, the greater than symbol, like we would with our equal sign. So if we want to think about it like that's where our equal sign would be. Now we just follow the rules of undoing any of those operations to get the variable by itself. So in order to get this x by itself, we want to get rid of this plus 5 by subtracting 5. And whatever we do to one side, we have to do to the other side, just like with equations. So this is going to cancel out that plus 5, and we get x is greater than 5. 10 minus 5 is 5. So we wind up with x is greater than 5 for that solution. Let's go on to problem 2. 17 is less than or equal to x minus 3. At the end of the video, I'm going to be talking a lot more in depth about these symbols and how to read them. So if that's something that is maybe a little bit confusing for you, stay tuned for that. So let's go ahead and if you want to drop your line down, I know a lot of students like to do that. Drop your line down. This time we're dropping it through the inequality symbol instead of an equal sign. We don't have an equal sign. And now we're going to get rid of anything that is over on the right-hand side since x is over here on the right. So we need to get rid of that minus 3 by adding 3. So we're going to add 3 to both sides. That's going to cancel that out there. And then we've got x. We're going to keep that inequality symbol, less than or equal to 17 plus 3 is 20. Now, some students like to rewrite this whenever we have the variable on the right-hand side. Some students like to rewrite this so that the variable is first, and that's perfectly fine. So we can start off with x, but if we're going to flip that x over to the other side, we also have to flip this symbol. So we need to write it as x is greater than or equal to 20. And that is because if we're reading this 20 is less than x, that means that x is on the bigger side of this inequality symbol. Well, that still has to be true even if we flip it around. So that x still needs to be on the bigger side, that open end of the inequality symbol. So both of these, either of these would be a correct solution for this problem. All right, let's take a look at number 3. 50 is greater than or equal to 10x. So again, in order to get rid of that multiplication of 10, we're going to divide by 10, and we're left with x on this side. 50 divided by 10 is 5, and again, we're keeping that inequality symbol. If we want to flip it, we can do that. We just have to also flip that inequality symbol. So both of those are correct. We can put an or in between there. All right, and then our last problem, x over 2 is less than 14. So remember, a fraction is just the same thing as division. So x divided by 2 is less than 14. So in order to undo that division of 2, we're going to multiply both sides by 2. That's going to cancel out here, leaving us with x is less than 28. Now, it's a good idea to check your work. So just like we do with equations, we want to substitute something into that original inequality so that we can check to make sure that our solution is correct. The difference with inequalities, though, compared to equations, is that with equations, a lot of times you get just a single value that is the solution to the equation. So there's just one single number that is the solution. Whereas with inequalities, there are many solutions. Let's go back up to this first one. Let's think about what x is greater than 5 actually means. X stands for a number that we don't know. So what we're saying with this is that x could be any number as long as it is greater than 5. So x could be 6, 7, 8, 100, 1,000, 1 million. Any of those numbers would be numbers that x could be and would satisfy this inequality. So let's check our work by choosing one of those numbers that's greater than 5. So I'm just going to go with 6. 6 is the next integer that's higher than 5. So I'm going to substitute that in for x and then rewrite the rest of my inequality just like it is in the original form. So then let's just solve this side. 6 plus 5 is 11, and 11 is greater than 10. So we know that we have our inequality set up the right way. Our solution is correct. Okay, let's go down here. Now we're going to work with those negatives. So I actually have two problems that are very similar side by side so that I can show you what you should do and what you should not do when dealing with negatives with inequalities. All right, so we have negative 6x is less than or equal to 12. So we need to undo that multiplication of negative 6 by dividing by negative 6. We're going to divide both sides just like normal. That's going to cancel out here and here. And that's going to leave us with x on this side. 12 divided by negative 6 gives us negative 2. However, we are going to go ahead and flip that inequality. So now it is x is greater than or equal to negative 2. And we can check our work just like we did before. So let me go ahead and box my solution here. So let's choose a number that is greater than negative 2. When you're checking your solutions, you want to check the inequality part, not the equal part. I could plug in negative 2 here and I would get that 12 is equal to 12. But what we really want to test is that less than or greater than portion of the symbol. So since we have a greater than symbol, I want to choose a number that is greater than negative 2. I'm going to go with just the next integer up, negative 1. Negative 1 is greater than negative 2. So I'm going to substitute that in right here. And then we'll check and make sure that this is correct. So notice that I'm using the original inequality symbol, that less than or equal to, and I'm using my solution once we flipped that inequality symbol. So negative 6 times negative 1 gives me positive 6, and that is less than or equal to 12. So we've checked our solution. We know that we're good to go. All right, let me show you with number 6 here. Again, very similar, but this time we are going to be dividing by a positive number. However, sometimes where students get confused when learning about this new rule with the negatives is sometimes the number that we are dividing is negative, but the number that we are dividing by is positive. When this happens, we do not need to flip the symbol. So it's only the number that we are dividing by, like we did in problem 5. So this is going to cancel out our 6's. So we get x, and then negative 12 divided by 6 does give us negative 2, but we are going to keep it as less than or equal to. So that is our solution for this one. We don't flip it unless the number that we are dividing by is negative, not the number that we are actually dividing, the number that's on top. All right, same thing with multiplication. For number 7, we're going to have to multiply because x is being divided by 3. So not only is x being divided by 3, but this fraction is negative. So we're actually going to take care of two things at once here by multiplying by a negative 3. That negative is going to cancel out with the negative in front of the fraction, and the 3 is going to cancel out with a 3. So we need to do the same thing over here on the right. So like I said, this all is going to cancel out with the negative and with a 3, leaving us with just x. And then negative 10 times negative 3 gives us 30. And then we are going to flip that sign because the number that we multiplied by is negative. So that's what is going to prompt us to flip that symbol. Now in problem 8, again, very similar, pretty much the same exact inequality, except that our fraction is not negative. So for this one, in order to cancel out that division of 3, we're just going to multiply by positive 3. So multiply by positive 3 on both sides. That's going to cancel out over here. X on this side, negative 10 times 3 gives us positive 30. But because this 3 isn't negative, the 10 is negative, that's true. But that doesn't make us flip the sign. It's only if the number that we were multiplying by is negative. So we're going to keep the greater than symbol for this one. Okay, let's do a quick review of how to read these symbols. So I know a lot of students that when they're first learning about greater than or less than, it's in elementary school and we are talking about an alligator wanting to eat the bigger number, right? I feel like we all have some version of that we have learned when we were in primary school. we're going to start using the terms less than, greater than, less than or equal to, greater than or equal to. And the way that we do that is by simply reading these symbols along with their numbers or variables from left to right. Just like we read in English from left to right, we're going to read these from left to right. So if your bigger number is first, followed by your smaller number, so if your symbol is opened up to the left like this, right, the alligator is eating the bigger number, then we would read this as whatever this number is greater than whatever this number is. So an example of that is this first example I have right here. We would read 7 is greater than 5, right? So we're just reading from left to right. Okay, and then on the flip side of that, when our symbol is pointing the other way and our smaller number is first, followed by our bigger number, we would read is less than, right? So the second example is an example of that. So we would read 3 is less than 4. So we're just always reading from left to right. So either your first number is going to be greater than the next number, or your first number is going to be less than your next number. Of course, we also have these symbols with the little line underneath. That means or equal to. So that means that this number can be greater than or equal to whatever number is following it. And it kind of makes sense because it's like one of the lines of the equal sign, and then the top line of the equal sign is replaced with either that greater than or less than symbol. So I just wanted to practice saying these, maybe pause the video, try these out, try reading them from left to right, and then resume and see how you did. All right, so for this one, we would read it as 100 is greater than or equal to 50. In this one, we would say negative 42 is less than or equal to 18. For this one, we would say x is less than or equal to 10. And for this last one, x is greater than negative 9. Thanks so much for watching this video on solving one-step inequalities. I hope it was helpful for you. This is part of my pre-algebra series. If you check out the link in the description below, I have a list of a ton of pre-algebra videos going over all of the skills that you might see in a typical pre-algebra class. So check that out. Also, please don't forget to like and subscribe, and I'll see you next time.